So let's go. So now we're going to deal with magnetic flux. So first, the magnetic flow across an open or a closed surface. Supposed a surface here, an open surface. Suppose the magnetic flux is in this direction. In a closed, in an opened surface. And suppose a box or a square with 3D square. This has, we are interested only in the surface of this box. So this we called closed surface. This is a closed surface. Now, the magnetic field in this mathematically is given by the following integral. No, this is the magnetic flux placed in a magnetic field is given by this integral over some surface of magnetic field times the normal vector, unitary normal vector times some ds. Mathematically, this is the magnetic flux. So next, the units of magnetic flux. If you the magnetic flux is magnetic field times area. So that is reasonable to say that the units of magnetic flux is Teslas times meters squared. In other words, is kilograms, seconds minus 1, coulombs minus 1 times meters squared. So this is called a unit called Weber. Weber, or abbreviate only Weber. For the German physicist Wilhelm E. Weber. Next, some interesting fact. So, one fact is that the first, so the lines of magnetic force are closed. the lines of force of the magnetic field field B the field B are closed. But also the flux, the magnetic field through a closed surface is, this is one fact. The second fact is flux of the magnetic field through a closed surface is zero, is always zero, is always zero. So that means that the inward flux through a closed surface is equal to, so that means that is the inward flux through a closed surface is equal to the outward flux. So equal to the outward flux. So graphically, if we have here that sphere and the magnetic field is in that direction, the lines of force of magnetic field is in that direction. So if the lines of force of the magnetic field is in that direction. So according with this preposition says that the flux inward, that is inward, the inward flux is equal to the outward flux. That means the inward flux is equal to the outward flux. So mathematically we can write a flux, magnetic flow around a closed surface. This means that it's a closed. This integral means that it's a closed surface. The spectre times u ds is equal to 0. Yeah, we got it. So the result is called the Gauss law. for a magnetic field. We can write this in the differential form. Writing the flux in the differential form differential we can say that the partial derivative of the magnetic field in x direction over dx plus the partial derivative in the magnetic field in the y direction dy plus is equal to 0, or the divergent of the magnetic fields is equal to 0. So I think that is all. So, but last, notice that you can express this fact into this differential form that has the same meaning. It says that the magnetic flux in the y direction plus the partial derivative in the y, the x, the y in the z direction of are, I don't know what, but the sum of this is 0. So that's all. Thank you.